Hi, today we're going to talk about the quotient rule. The quotient rule is one of the basic rules of derivatives. There's motivation for it, but I thought it'd be better just to see the rule and try it out. So, here's the rule. The derivative of f over g it's messy. Well, do you remember what the derivative of the product rule was? It was f prime times g plus g prime times f. So the f prime and the g kind of balance together, the g prime and the f balance together, and there's a plus in between. So that was multiplication. Division is kind of the same, but with a minus in between. Now minuses are tricky because minuses are not commutative. It's important to remember which one goes where. It's f prime g minus g prime f. Those are not interchangeable. And now it's also division, so there's something on the bottom, and it's g squared. Now if that's hard to remember, there are mnemonics. The one I always learned was the derivative of high over ho. The derivative of high over ho is ho d high minus high d ho over ho ho. Because it's the bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. It doesn't mean, you don't have to remember that if you don't want it. If this helps, it's great. If not, remember this one. Anyway, let's try some examples before I start singing silly math ditties. So let's take the derivative of this. I'll let you actually try both of these. Okay, hopefully you've got some time. And how do we do it? Well, it's f prime. It's the derivative of the top. What is the derivative of the top? X squared's derivative should by now be obvious to be 2x times the bottom minus the derivative of the bottom. This is in line. Its derivative is 1 times the top over the bottom squared. Now notice, two important things. First is, I'm not done. The top needs to be simplified. Second, I'm not going to multiply out the bottom, because usually, in most of these problems, you need to factor things. Since this is a factor, already factored thing, we don't need to do any more. The top, however, has two terms that need to partially cancel out. So let's do this. Just above it. 2x times this is what? 2x squared plus 2x minus x squared. I can cancel one of them. So I'm going to end up with x squared plus 2x for the top over x plus 1 quantity squared. Now, I could factor the top again. But unless I really need to, I'm satisfied with this. How about this one down here? Hopefully not much different. The derivative of, so it's f prime, right? So it's the derivative of that, which is 1 times g, remember that's a minus g prime, the derivative of the bottom. Now, hopefully, by now, the x squared's derivative, you recognize as 2x. What about the minus 4? Minus 4 is a constant. And if you think about it, it's a constant. A constant is just a line that's horizontal at some spot. So its derivative is 0. Times the top over the bottom squared. And it's the bottom. It's not the derivative of the bottom. So again, though, we want to multiply out the top so we can cancel pieces. What do I have? X squared minus 4, because that's a 1 there, minus 2x squareds, and the 0 goes away. I end up with minus 4 minus x squared on top over x squared minus 4 quantity squared on the bottom. There are a lot of x's, a lot of squareds, a lot of 4's, and hopefully it makes at least a little sense. Let's close with one more example. This one has to do with this function. I'm asking where it has a horizontal tangent line. So where's the tangent line? Flat. Now, that means, what's the derivative? Horizontal tangent line, the slope of the tangent line is the derivative. So horizontal tangent line means the derivative is equal to 0. So I need to find where the derivative of this is 0, which means I have to find the derivative. X over x squared plus 1's derivative. F prime, so the derivative of x, times g minus g prime, the derivative of the bottom, It's very similar to the previous one, but it's got a plus 1 instead of minus 4. What is it? The derivative is 2x times the top over the bottom squared. I need to simplify the top. I'm going to do it in my head here, but I get 1 minus x squared. Why? Actually, I better not do it in my head. Yep, it's 1 minus x squared over x squared plus 1 quantity squared. Now, horizontal tangent line. I'm not done with this. That is simplified derivative, but it's not answering the question. Horizontal tangent line. 0 slope. So when I have a fraction, if a fraction is 0, that means the top is 0. Doesn't mean the bottom is 0. Try it. 3 over 0, not 0. But 0 over 3 is 0. So 1 minus x squared is 0. What makes that 0? I can bring the x squared over. Let me try that. 1 equals x squared. Square root both sides. But if you do this and you get x equals 1, you're not right. What did I forget? This step's good. This step's good. What's wrong here? What's wrong here is when you square root, you got to remember your pluses and minuses. Because minus 1 also works. Try it. Minus 1 squared is 1. 1 minus 1 is 0. Those are our answers. That's where this is horizontal. Until next time, this is Dr. J.